In this video, we're talking about potential energy. And we have a lot of different types, including gravitational, chemical, elastic, electrical, and so on. We are mostly going to focus on gravitational energy. And basically, it's energy that is stored in one form, but we could change it to some other form of energy, like thermal energy, which is heat, or kinetic energy that we learned about in our last video. So now I want you to think about how this relates to work. If I have a 1 kilogram box and I lift it 1 meter, we could do some math and figure out how much work that was. But right now, I just want you to compare between a 1 kilogram box and a 2 kilogram box. Both of them are being lifted 1 meter. So yeah, the 2 kilogram box is probably going to take more work to lift. And so we could say that it has, after we've lifted it, we could say it has more potential energy than the first block because it has more mass. But what about this? I have a third block that is also 1 kilogram, and I'm lifting it 2 meters. So compare the first block and the third block, both of the 1 kilogram blocks. Which one is going to take more work? So which one is going to have more potential energy after we lift it? So most of you probably decided that this one, since it went further, I had to do more work to lift it, and so now more work means it has more energy. But what about these two, the 2 kilogram block that moved 1 meter and the 1 kilogram block that moved 2 meters? To really figure out which one has more potential energy, we're going to have to do some math. To do some math, we got to have an equation. So we got potential energy from gravity equals mass times g for gravity, that negative 9.8 meters per second squared, times h for height. That's the height that we have lifted it up, or the height above the ground. So now that we know that, we can start using that to apply into our situation here. So it says which block has the most potential energy. Anytime you have a situation like that, you need to think, what equation am I going to use? So hopefully you remember from our last slide that potential energy is just mass times gravity times height. I put 1s for this one because that's going to be for our first block. I put 2s for this one because that's going to be for our second block. And I put 3s for this one because that's our third block. So now we just got to plug things in. So what is the mass, or what's this whole equation going to be when I plug in my values that I know for the first equation? All right, so hopefully you were able to come up with something like this. We got 1 kilogram times 9.8 meters per second squared times 1 meter. You may be looking at this and thinking, time out, Mr. Schobert, you did something wrong. You forgot something. As it turns out, though, I did that on purpose, and that's because, usually we use negative 9.8. Whoa, real sloppy. Okay, negative 9.8. And all that negative is really telling us is that we are pointing down. Gravity is pulling us down towards the Earth. And we could include it here, and then we could say, well, our change in position was actually down as well. And so if we did final, it was down here, minus initial up there. We actually had a change. 0 minus 1 would be negative 1, so we put a negative there. But those are going to cancel out, right? If I have two negatives and I multiply them, they cancel out. So I would actually say it's probably easier on all of us if you just don't put a negative. And I'm telling you, that's okay right now. This is kind of a wishy-washy thing anyways, and the negative really is just telling us a direction. So now that we got that, we can plug that into our calculator, or we might not even need to plug it into our calculator, and we can just see that the first block has 9.8 joules, remember joules, kilogram, meter squared per second squared, of energy. So that was pretty easy. I'm going to let you guys figure out do the same exact thing, plug in things for situation 2 and 3, and see how much energy, potential energy from gravity we have for each of those blocks. Okay, so this should have been pretty straightforward, just plugging in each number into the appropriate equation and then sticking it in a calculator and figuring out what you come up with. And you should have noticed that these two are actually the same number. And that kind of makes sense. This one was twice the mass as this one, but this one went twice as far up as this one. Or you could think about it the other way around, is it has twice as far to fall. This one's only going to fall 1 meter. This one's going to fall 2 meters, so it's got twice as much energy. Twice as far to fall, but only half the mass, so kind of balances each other out. So then, overall, this question says, which block has the most potential energy? Well, there's not really one block. It's that number 2 and 3 are tied for first. So hopefully this helped you understand how to use some potential energy equations in your questions in your homework.